Alright, what do we got here? We got a study guide for Unit 5. I gotta hurry. See if I can get a page done before I have to go open the room up. Alright, if S denotes the length of the arc, so notice they talk about length of the arc. So I'm gonna write me a little formula. It's S equals R theta. Blah, 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 find the missing quantity. Alright, so S is 4.59. Theta is 2.7 radians. 4.59 equals 2.7. And I don't know what the radius is, R. So I just divide both sides by 2.7. I say round it. It doesn't even say about find the missing quantity or rounding. And I gotta wait on the calculator. 4.59 divided by 2.7. The radius is 1.7 meters. All right. Number 2, find the length S. Round the answer to the nearest to 3 decimal places. And again, your formula is S is R theta. S, by the way, being arc length. I don't know why it's called S. But if this was a circle, this would be my radius. So 10 times pi over 5. That's going to be 2 pi when everything's said and done. Which is like 6.28, isn't it? They want 3 decimal places though. 6.283. All right, number 3. If A denotes the area of the sector of a circle of radius r formed by the central angle theta, find the missing quantity and area. Area is 1/2 r squared theta. I'm just going to plug some crap in and be done with it. The area is known to be 39. The radius is 6. And that's squared. We want theta. So 6 squared is 36. Half that's 18. 39 is 18 theta. So theta is going to be 39 over 18. They want 2 decimal places. 39 over 18. 2.167. Or 2.17. Find the area. Round the answer to 3 decimal places. And again, the area is 1/2 r squared theta. That guy has to be a radian. So I'm going to take my 35 degrees. I'm going to multiply it by pi over 180. And I'm going to reduce that on down. See what 35 over 180 simplifies to. 7 pi over 36. And that is going to go there. There's my radius. So my area is 1/2 of a 6 squared times 7 pi over 36. Interesting enough, those cancel because 6 squared is 36. And my area is 7 pi over 2. Which is about almost 11 on the money. 10.99. They want that to 3 decimal places. So about 10.996. That was square yards, right? Square yards. I think there's 25 questions on this study guide. Number 5, a car is traveling at 33 miles per hour. Its tires have a diameter of 28 inches. How fast are the car's tires turning? Express the answer in revolutions per minute. Most of you had some experience with this question on my open math. All right, so I have a diameter of 28 inches, so my circumference is 28 pi inches. This needs to be in inches per minute because they want revolutions per minute. So 33 times 5280, that's going to get me in feet, times 12 gets me in inches. And there are 60 minutes in an hour, so divided by 60, there we go. 34,848 inches per minute. Why did I do all that? Because now I can figure out my angle here. The angle is defined to be, or sorry, not angle, omega, which is angular speed, It's got a couple of different formulas. It's theta over time. Or what else is she? Actually, they just want pure RPM, don't they? Ignore me. Having a brain fart. They want revolutions per minute. Your RPM is going to be simply to take the inches that you're covering, 34848, divide it by 28 pi. That'll tell you how many times that, I can't talk, that will tell you how many times that tire travels to cover that distance. Oops, got screwed up. There we go. 396 point, they say 2 decimal places, 16. And by the way, there is a key attached to this thing. So, you know, if I'm a little curious, I can go to the key. There she is. If I missed something, I could check it. Oh, like, look there, number 3, they have in degrees. I didn't do that. See, I'm glad I mentioned that. Back to this. This is a radian, right? So 2.17 times 180 degrees over pi will give me my actual measurement in degrees. There we go. About 124.33 degrees. And I probably rounded here, so that's going to be a little bit off. All right, back to this. I don't know what noise that was. Number 6. The secant is 4 over 3. Find the cotangent, and it mentions using identities. See, it says use identities. All right, so I need to be thinking about some things here that might relate secant and cotangent. Let's see here. I'm going to start with this one. Sine squared plus cosine squared is 1. If I want secant, I'm going to divide out cosine squared. This will give me that tangent squared of something plus 1 is secant squared of something. Now I'm going to plug that bad boy in right there. Although I could have done something else. I don't know why I did this the hard way, but I did. Tangent squared of theta. In fact, scratch this. If secant is 4 over 3, cosine is 3 over 4. Sine squared plus cosine squared is 1. Just going to plot that there. Sine squared plus 3/4 squared is 1. 3/4 squared is 9/16. So sine squared of theta plus 9/16 is 1. I'm going to subtract 9/16. Sine squared of theta is 1 minus 9/16, which is 7/16, which means that the sine of theta is going to be square root 7 over 4. Now, I want cotangent. The cotangent of an angle is cosine over sine. So cosine was 3/4. Sine was root 7 over 4. 4's cancel, whether Harley likes it or not, they do. That leaves me with 3 over root 7, which is 3 root 7 over 7. Ta-da! And I need to go and pause this video and go unlock the classroom. Got to open up dual enrollment. I'll be back in a minute.